It sounds almost like the plot of a science fiction movie, but it's reality. A few years ago, a very strange object entered the solar system, immediately puzzling experts. Named Oumuamua. This flying object not only had an extremely unusual composition and no comet-like coma, but also exhibited flight behavior that could not be explained by the influence of gravity alone. In the aftermath, there was only one question left. What on earth is Oumuamua really? Is it just an unusual but purely natural outgrowth of the cosmos? Or could it be that an extraterrestrial civilization has sent a spaceship to our home system? In fact, the alien theory is not only circulating in relevant internet forums. It was first put forward by a renowned Harvard professor, but now astronomers believe that they have finally uncovered the true origins of our interstellar visitor. It's a question that is probably as old as humanity itself. Aren't we really alone in the universe? Could it really be that Earth is the only place in the entire cosmos where life could have emerged? There is no question that we ourselves have tried to make contact with our possible contemporaries. After all, we've sent messages into space several times with the Voyager Golden Records and the Pioneer plaques, but unfortunately never received a reply. Fortunately, however, this does not mean that we have to sit and wait. Thanks to technical masterpieces such as the James Webb Telescope, we can now actively search for traces of extraterrestrial life and perhaps soon come a step closer to solving the great mystery. Although the main task of the high-tech observatory is to track down the oldest luminous objects and galaxies in the universe, it also focuses its sharp infrared gaze on the atmospheres of distant exoplanets to investigate their potential habitability. And in 2023, the most powerful space telescope of all time made a remarkable discovery. Two discoveries, in fact, which scientists have named K2-18b and which are located around 124 light-years from Earth. On the one hand, the 2.6 Earth-radius celestial body orbits within the habitable zone of its home system. And on the other hand, it's suspected of being a high-Cean world covered entirely by water. And since water, as we understand it, is the elixir of life, K2-18b is also considered a hot candidate when it comes to the possible home of extraterrestrial life forms. However, this promising starting point alone is not enough. But fortunately, it doesn't have to be. In fact, 2 years ago, Webb discovered the first evidence of dimethyl sulfide or DMS for short on K2-18b, a special sulfur compound that is only produced on Earth with the involvement of living organisms. Since we do not know of any abiotic synthesis pathway by which this molecule could be produced, DMS was immediately considered a potential biosignature. But what exactly is it? Well, it's a molecule that is produced by plankton and during the decomposition of organic substances and is responsible among other things for the typical smell of the sea that hits our noses when we go to the beach. However, and this is the decisive factor, Webb's sensational discovery also had a crucial catch. On the one hand, the DMS signal from K2-18b was not particularly strong, and on the other hand, it was only detectable when the data was evaluated in a very specific way. This was because the supposed biosignature was found by the near-spec near-infrared spectrometer, which meant that it overlapped so much with the methane signal that the values of the two molecules could not be clearly separated. To determine the true significance of the discovery, further investigation was therefore essential, and that is exactly what Webb did a few weeks ago. This time, however, it was not near-spec but the mere spectrometer that targeted the distant water world and identified something that could go down in history as the greatest space discovery of all time, the strongest indication of extraterrestrial life. While the spectral line detected by the near-spec instrument was still visible at a wavelength of 3.4 micrometers, MIRI operates in the mid-infrared range, more precisely between 6 and 12 microm. And that is precisely the crucial point. In theory, dimethyl sulfide and some other potential biosignature gases should leave much clearer signatures in this wavelength range than in the near-infrared. And in practice, they did. Webb's reanalysis revealed distinctive peaks in the wavelength range between 6.8 and 8 micrometers and between 9 and 11 micrometers. A subsequent comparison with the expected spectral lines of 20 different molecules yielded a clear picture. There is little doubt that the signatures detected are attributable to dimethyl sulfide and/or dimethyl dulfide. Niku Mathusudhan from the University of Cambridge, who led the underlying study, explains, Our data confirm the clear presence of only two molecules, DMS and DMDS. Even more important, however, is the high significance of the discovery. The bottom line is that the probability that the measured spectral signature actually originates from DMS or DMDS is an impressive 3.2 standard deviations. The probability of the existence of at least one of the two molecules is also around 3 sigma, meaning that the chance of pure coincidence or measurement error is only 0.3%. In other words, we now know of an exoplanet where there is a 99.7% probability that at least one of the gases that according to current knowledge can only be produced by biological processes is present. The new measurement data therefore suggests the groundbreaking conclusion that life may have developed on K2-18b. At the same time, the extraordinary intensity of the spectral signature indicates a very high concentration of biogenic molecules in the atmosphere of K2-18b. It's over 10 parts per million, about 1,000 times higher than the corresponding value in Earth's atmosphere. Mathusalem comments. These amounts indicate very strong biological activity on the planet. This is consistent with what has been predicted for such high worlds, and that is exactly what we have now observed. Given what we know about this planet so far, the ocean of this water world could be teeming with life. What hurdles still need to be overcome? So, we may have found a planet that is practically overflowing with life. But how is it that the alien question has still not been definitively answered? If DMS can only be produced by living beings and it has been found on K2-18b, isn't the matter clear? Well, unfortunately, not quite yet. Because Webb's observation has not yet achieved official discovery status. A discovery is only considered as such when it reaches a significance level of 5 sigma, which means that the probability of pure coincidence must be no more than 0.0000.6%. However, this hurdle could soon be cleared. All it would take is the observation of a few more transits of the planet, which would correspond to a Webb observation time of only 8 to 24 hours. And even if the last doubts about the existence of DMS and/or DMDS are then dispelled, that does not mean we can pop the alien champagne. In simple terms, scientists do not assume that they have already reached the pinnacle of wisdom. In other words, just because we do not know of an abiotic formation pathway for the molecules does not mean that one does not exist. In fact, experts have already conducted initial investigations into this, but so far they have not been able to find a chemical reaction that could produce these gases on K2-18b without the involvement of organisms. Despite this, experts continue to urge caution and emphasize that it cannot be ruled out that such a reaction may still be discovered in the future. But if, and this is the exciting part, the supposed biosignature is ultimately confirmed as such, it would be nothing less than one of the greatest sensations in the history of research. We're talking about a discovery that would dramatically change our view of the cosmos in one fell swoop. And Mathusalem sums up this thrilling possibility as follows: decades in the future, we may look back on this moment and see that it was decisive. This could be the turning point when the fundamental question of whether we are alone in the universe can suddenly be answered. In other words, we now know of an exoplanet where there is a 99.7% probability that at least one of the gases that, according to current knowledge, can only be produced by biological processes, is present. The new measurement data therefore suggests the groundbreaking conclusion that life may have developed on K2-18b.